Hey guys, welcome back to another episode of Flat Earth and Coffee. I'm your host, Bobby Thompson, and in this episode, we're going to be talking about all of the many statistical impossibilities that make the heliocentric model impossible. So let's jump right in. The first thing I want to talk about is the second law of thermodynamics, which states as one goes forward in time, the net entropy, or the degree of disorder or chaos, of any isolated or closed system will always increase, or at least stay the same. So in essence, time tends towards chaos or disorder. Now let's look at our first statistical impossibility, which is the impossible timing of the sun, which I call the celestial Rolex or the celestial clock. There are 86,400 seconds in a day, right? In a geocentric model, it is the sun completing a circuit above the flat Earth, which gives us a solar day, right? Which is 86,400 seconds. And I want to talk about how accurate that 86,400 seconds is. Let's compare that to an atomic clock. According to popular mechanics, an atomic clock loses a second only once every several billion to 1 trillion years. Wow, man, that is like there's nothing on Earth that accurate. An atomic clock, 1 second in a trillion years. According to Time and Date, an atomic clock can deviate 1 second in 100 million years. These are inconceivable ratios. What about NIST, National Institute of Standards and Technology, accurate to within 1/15 billionth of a second per year? These are, so what these should be, first off, if you ever read something like that and believed it, you don't have a scientific mind. All of that is bullshit. Why is it bullshit? Because how can you make a claim like that without a source to compare it to? So what are you comparing your atomic clock to? Are you comparing it to a Rolex? Are you comparing it to a Timex, to a Casio, to some digital clock? What are you going to compare it to make that claim? How can you quantify that? You can't. But every timepiece in the world is compared to the sky. That is, the sky is what dictates time. Does man dictate time, or does the celestial clock dictate time? I say it's the celestial clock, right? There's nothing more accurate than that. And apparently it's so accurate that atomic clocks can be within a 15 billionth of a second per year. Wow. Now, there are testaments to that accuracy. One of those is Konark Temple in India, which is a megalithic site that has several sundials. And it's claimed to have been built in 1250 AD, which would make it about 774 years old. Still accurate to the minute. Let's watch this video.
Okay, so I put finger in axle, but my shadow is there. 6, 7:39, 10:30. So cross the 10:30. So now time is 11 plus some 10. 11:10 होगा.
Now there are many other videos of Konark Temple. You can just YouTube or any video site and check out Konark Temple, and you'll see them using this sundial to tell the time, and then they'll ask the crowd, hey, what time it is, and someone will look at their watch, and it's accurate to the minute. If you'll see, if you watch, that this wheel has a number of beads that go around it. Each bead represents 3 minutes, and the beads are big enough that you can break the bead into thirds. So still accurate to the minute, 774 years later. Now, what about Anthem Veterans Memorial in Anthem, Arizona? Every day at 11:11 a.m., it casts this image onto the ground, and it's perpetual, right? So that testifies to the timing of the sun. The sun maintains a perfect circuit perpetually. That's impossible. No explosion can create that. But what about the movement of the luminaries, right? Well, if we do a time lapse of the pole star or Polaris in the north, and we just leave the camera there, and this long exposure will yield this photo right here, which is concentric circles. So we can't see any movement of the stars. And just to drive that home, there was a monument called the Georgia Guidestones, which was destroyed in July 26th of 2022, and it had this hole drilled in one of the monuments in one of the stone structures. You could look through that hole and see Polaris every night of the year, as long as that thing was there. It was destroyed by someone, nobody knows who, but maybe that's the reason it was destroyed. Maybe word was starting to get out. But let's talk about the relationship of the luminaries now, not the concentric circles, which is one impossibility, another impossibility, which is the lack of parallax. So what is parallax? This is parallax. Parallax is when you see an object in a foreground as you're move past the object in the background. That's what you'd expect to see if we watch Star Wars, Star Trek, Lost in Space, Buck Rogers, whatever sci-fi film we're watching. We expect to see this. Our brain tells us we should. But what do we get rocketing to the cosmos at 1.2 million miles an hour? We get this. We get stars locked in relationship to each other that instead turn as a whole unit, almost like a firmament. So we don't observe parallax. What about the patterns that we've observed, aka constellations? Well, I added this because of the first line. A constellation is an area of the celestial sphere in which a group of visible stars forms a perceived pattern or outline. I like that they use celestial sphere, right? We believe in a hemispherical dome or a half sphere. And what's the irony that if you go to, one way you can study the stars or see different depictions of them is to go to a planetarium. And what is it? It's a hemispherical dome. What do the constellations ever change? As long as we've observed the constellations, they have never ever changed. And why? Because the stars are so incredibly far from us, right? It's always too far or too big or too heavy. There's always some excuse of why we can't observe it, right? Why we can't, why it's immeasurable. So here we are, doing, rotating at 1,000 miles an hour and orbiting at 66,000 miles an hour and rocketing at, 500,000 miles an hour. And we have all these different trajectories and orbits and spins, but nothing moves. Nothing moves. None of these luminaries change in relationship to each other. What about, here's another statistical impossibility, the size of the sun and moon in relationship to each other? Well, science will tell you that the sun is 400 times bigger than the moon, but it just happens to be 400 times farther away. What are those odds that it's 400 times bigger? Not 401, not 389, but 400 times farther away. That is impossible, right? But you have to believe that. And that is science. That's why I added this slide, because that is what physics teaches, right? As it happens, even though the moon is 400 times smaller than the sun, it's also about 400 times closer. Now, they just did the inverse explanation of that, but stating the same exact thing. And that is how we can get this, a solar eclipse, when the moon supposedly passes in front of the sun, and we see this blackout of the sun that is perfect, right? In their dimensions, they are the same size. Yet one is 400 times bigger, or maybe, just maybe, they're the same size. What about a Saros cycle? I think that's statistically impossible. So easy, a Babylonian can do it. A Saros cycle is an 18-year cycle which has continued perpetually since being discovered by the Babylonians. Right, this is, you can see that you can look this up. This is from Encyclopedia Britannica, but NASA has articles on it as well. You can still use a Saros cycle today. They are still accurate. This was, the Babylonians are credited with it going back to 500 BC, which would make it about 2,520 years old. That means Saros cycle, this 18-year cycle, has been going on for 2,520 years, perpetually, perfectly, with precision, as we're rocketing through space, spinning, orbiting the sun, shooting through the cosmos, 1.2 million miles an hour, right? What are the odds of that? It's impossible. All these impossibilities stacked on impossibilities, stacked on, it just can't be, right? What about the perfect sphericity of the moon? The moon is a perfect sphere. How did that happen? How did it get chiseled down in space where there's no friction whatsoever? Where did the moon come from? Why is it perfectly spherical? Why is there no hot spot on it as well? But what about the phases of the moon? The phases are another statistical impossibility. That is, we see the same phase continuously. It has never changed every 29.5 days, according to science. This phase is perpetual and never changes. All of these things, there's so many statistical impossibilities, and all of these things are all happening at the same time, all stacked on top of each other. We're not going to play the whole thing, but you get the point. We've only ever seen one side of the moon. What are the odds of that? Exactly 50%. Unless you believe in, we went to the moon, and this is a photo from Apollo 16 where they were able to get a picture of the backside of the moon. Wow. If you believe that, I feel sorry for you. Here's the front of the moon. Look at this. There's the front. Why is the back, if you believe in this, why is the back why are the craters so much more pronounced? Why are they so much deeper? Are they implying that the back is getting hit harder, or like the front's protected by the Earth or something like that? I mean, the moon's supposedly 236,000 miles out. It can be hit by all kinds of angles. And if it were being hit more so, or by bigger objects in the back, if the front is being protected, wouldn't one of those cause it to spin? What about orbital periods, the perfect timings of the planets? Mercury has an 88-day orbital period. It is 88 days perpetually, 88 days, 88 days. This is another clock unto itself. It's its own timepiece, telling its own time. It is on a perpetual 88-day circuit. What are the odds of that? With, all these tugs and pulls of gravity going on, right? And movements, and how do we get that? Why does Venus have a 225-day perpetual orbit? Why does Mars have a 687-day perpetual orbit? We can measure this again and again and again. Why does Jupiter have a 4,333-day perpetual orbit? It's perpetual. It will do this. We can observe it. It'll always go back to the same place. All of these things are keeping their own time. Why does Saturn have a 10,756 Earth day orbit? Pretty specific, because if it weren't doing a constant speed, they could never make that prediction to the day, right? Now, you may see a source go say, 10,759, or 10. Once they start getting into time frames that are outside of your lifespan, they can skew the numbers then, just to go, well, it's rough, right? The ones that are in our lifespan, they can't skew the numbers, because we can watch it come right back to the same place, right? So I say science is a liar. What about Uranus? Uranus has a 30,687 Earth day orbit perpetually. What about Neptune? It has a 60,195 day orbit, according to Wikipedia. But NASA backs all these up. What about, what is this, Pluto? 248 Earth year orbit. Wow, I didn't even bother to put that into days. What's it matter? But look at this. This is from NASA. A lot of those weren't from NASA. Basically, NASA dictates the science. NASA tells everyone what it is. Many of these are factual, right? I'm sure Mercury, Venus, Earth, Mars, the ones that, Jupiter, once you start getting out into, tens of thousands, I don't know. It's beyond our lifespan. Orbital resonances. Too many impossible timings. First off, what is an orbital resonance? It's this. Now, orbital resonances, there's many different types of resonances. In science, they only call something an orbital resonance if the integers are whole and if they meet on the exact same axis again and again, which is like, to me, there's no odds. There are no odds. It's impossible to do this perpetually. And we do see this with multiple systems in the sky. It's observable from Earth. Multiple systems in the sky having these perpetual resonances. And here we are, just another, this is an actual orbital resonance. This is Jupiter with going from the inside out, Io, Europa, and Ganymede. And if you see every time that flashes, they're lining up exactly and it's a 4:2:1 ratio, right? The outside, anyway, we're going to go into this in more detail. We're going to have a slide just on Jupiter later. I just did this to demonstrate what an orbital resonance is. And you can see how they all have to line up on the same line? All right, you get the point, right? We don't have to drone it out. My point is they only consider it an orbital resonance if it does it on the same, and they did that to hide the fact that there's even more resonances, even more. They don't when it's not a whole number, they don't call it an orbital resonance. If it's, we'll get into that. Now, what about, does Mercury have an orbital resonance? Yes, for every 2 orbits of Mercury around the sun, it rotates 3 times. There are different types of resonances. This is called a spin orbit resonance, which is just as crazy. And here's a graphic of that, sped up for brevity's sake. And you'll see that for every 3 rotations, there are 2 orbits perpetually. Exactly. It's going to do this forever. We can observe this in the sky. Now, what about Venus? Does Venus have an orbital resonance? Well, supposedly, according to science, that with Earth, it has a 13:8 mean motion resonance. When it's mean, it means it's exact, right? And you can read about that in the little black bar. But let's look at that. What does it look like? Well, it means if we look up, you can represent that these resonances will show up as geometric patterns. So if we look at Venus transiting our sky from Earth, we'll see Venus make this pattern in the sky. And there's something called well, if we come to Jupiter, it makes what's called a Laplace resonance. It's a 3-body resonance with a 1-2-4 orbital period. I can only find one Laplace resonance. I don't know if there's others. This article from, I didn't put where it's from, but it said a Laplace resonance occurs when 3 or more orbiting bodies have a simple integer ratio between their orbital periods. For example, Jupiter's moons Ganymede, Europa, and Io are in a 1-2-4. Now, just having a 1-2 is already crazy, but now you've gone 1-2-4. It's perfection on top of perfection on top of perfection. Let's look at that. Let's look what this looks like. Do you see? They have to line up on the same line, and there's 3 of them with perfect resonances amongst all 3 of them. I mean, this is called a Laplace resonance, and it's absolutely crazy that we can observe this in our sky. So it's like another clock unto itself, another perfect harmony. And this coming from space.fandom.com, no explanation has been found for the contrast between the satellite systems of Jupiter and Saturn, in both which the majority of major moons, 3 of Jupiter's and 4 largest and 6 of Saturn's 8 largest, are involved in mean motion resonances. And if it's a mean motion resonance, it means it's a whole integer, which makes it even more, impossible, which is why this article goes on to say no explanation has been found. In other words, even science knows it's so uncanny. It just can't happen, right? And apparently I was wrong when I stated earlier, there's already 2 occasions when it happens. It happens with Saturn's moons and with Jupiter's as well. And so we already saw Jupiter's. Here's another thing that happens with Jupiter. Apparently we can observe this in the sky, which there are 2 distinct groups of asteroids that have 2 distinct resonances. And this goes on perpetually because a resonance is perpetual. Look at that. Can you imagine looking up in the sky and seeing this going on? Now, what about Saturn's moons? There are 3 different known resonances just with Saturn: Mimas and Tethys, Enceladus and Dione, and Titan and Hyperion. And here's just Titan and Hyperion, leaving out the other 2 sets, right? Because there's 3 sets all in perfect MMR. This is crazy. This is all statistically impossible. This is actually about Saturn's rings. They have resonances as well. And you see this 2-1, 3-2, 4-3, 5-4, and you can see the ring it applies to. So apparently the rings move at different observable speeds. This is phys.org. This is their claim, although I've seen the claim on other websites. I haven't verified this, but This is even more, this just adds to how detrimental this is. If all these resonances do indeed exist, which science is telling us that they do. Here is Jupiter and Saturn in a 3-2 resonance, and you can see they meet on this one line again and again and again, right? That will go on perpetually. What about, and here is that same Saturn and Jupiter. If we observe them in the sky, this is the geometric design that it makes, right? So these resonances create designs because they're, if you can take objects that have resonances with each other and like draw a line between them and then let that line demonstrate these geometric designs. Now, what about Neptune and Pluto? They're in a 3-2 resonance. I don't have a graphic for that one, but it's in a perfect 3-2, and you know that because it's a mean motion resonance. So where's the chaos? Where is the chaos in our universe? Wanted to talk about some, or show some videos of other magical geometry. Some people call this the dance of the planets. Let's look at Mercury and Mars. If we observe Mercury and Mars from Earth, that's the design we will see. What about Mercury and Saturn? Look at how perfect that is, right? Look at how absolutely perfect. Now, these are only a few. There are many, many more. For brevity's sake, I only put a handful of these. Here's Mars and Venus. And this is what science tells us. These are the patterns that we can observe, but we know there are many, many sources that tell us we see these, and you can use software like Stellarium, which will, it jives with what we see in the sky at any point in time. Let's look at Jupiter and Mars. These geometric patterns, which prove these resonances, they verify, they're a testament to each other. Here's Saturn and Neptune. Okay, my PowerPoint crashed, interesting. So here we are back with, here's Saturn and Neptune. And again, this is perpetual. This will go on, this pattern will draw itself again and again and again. Here we have Uranus and Mars. And look how perfect these are. What about Neptune and Mars? What about Pluto and Uranus? What about Pluto and Neptune? It's an interesting symmetrical design. It is symmetrical in one sense, top to bottom, right? So all of these motions not only violate the second law of thermodynamics and all statistical probabilities, but also the theory of gravity. And let me show you what I mean. There is something, if you're not familiar with, called the classic three-body problem, or just the three-body problem. But the world's largest astronomy museum in China was inspired by the classic three-body problem. So what is that problem? Well, in astronomy, the problem of determining the motion of three celestial bodies moving under no influence other than that of their mutual gravitation. No, we can take this word general out. There's no solution of this problem, or a more general problem involving more than three bodies is possible, as the motion of the bodies quickly become chaotic. Anytime you take three or more bodies in a system, we can say a solar system, any gravitational system, any system that would depend on gravity, you can only make any type of system work that has two bodies. So you can take a massive, if you make a center object massive enough, and you put a tiny satellite around it, you can get a perpetual orbit. But the moment you put a third body on it, it quickly goes to chaos. So our solar system, as with any gravitational system you can observe in the sky, as many of those resonances would be, they're all impossible. There's no mathematical equation that we can put together that can create those, which is why we had to throw out Newtonian gravity, right? Which is why we have Einsteinian gravity, where gravity is no longer a force, and now we invoke this this fabric of space that bends and warps. So for those people who still think gravity is mass attracting mass, that's already been disproven, right? And we know that because of the three-body problem. There is no solution There's no mathematical formula we can put into a computer, which if gravity were real, we would be able to do that. But we can't do that and have ourselves, which is why we have this magic matter that acts like a little, a little fairy that pushes on planets and holds them in place, that we can't explain why it does that. And I just wanted to close. In closing, I wanted to say there is a creator. Seek the creator and you will find the creator. You will see it is evident that he has put his signature on everything. And I wanted to play this last slide. It only takes a second. These are all, things in nature out there. These are real. I've added where I could find them the scientific names and their common names. But how can you not believe there's a creator? How can you think that these things can just create themselves and mimic life so perfectly? It's almost like nature's looking back at us. Not one of these is fake or Photoshop. These are all real. I've verified them all. Feel free to look them up yourself. You can believe it's just a coincidence, just like you can believe all those things that we just went over are coincidence. There are too many impossibilities. One of those, just one, just the distance from this, the distance and sizes in relationship to the sun and moon, it's already impossible. It couldn't happen. All of these things stacked on top of each other. There's no possible way. I hope you enjoyed the video. Until next time, my friends, take care.